Welcome to another Geometry Nodes tutorial. In this video I will show you how to create light with geometry nodes and how to use it to create cool effects based on the light brightness on the surface. So let's get started. I will start with this monkey head here, Suzanne, to display the brightness on her surface. So let's enable the material preview to look at it from Eevee's perspective and open the Geometry Nodes editor, create a new group, and let's get started. So the problem is basically that we can't put light information from the shader into the Geometry Nodes editor, so we have to build our own light basically. But that's not a very big issue, because if you look at the render equation, you can see that there are two main components of the light calculation, which is at first the angle. If you have a light here, you have angles which look in the direction of the face and angle which look away like this. And these areas will be bright and these areas will be dark because the angle points away from the light source. That's basically the main component, and additionally to that we can multiply that with the distance here. So when we have a low distance between the points of a surface and the light here, the light source, then the brightness can get increased with a multiplier. And when faces are pointing to the light like this also, but are further away here, then it will be a little bit darker. And by this we have an approximation to the light which will be enough for us, because we will only display the rough brightness and this is totally enough for this. So let's add a empty object which will be our reference point for the light source, like here. And then I want to bring this empty into my Geometry Nodes editor on the relative. And now I can start calculating, because let's put this away for now. It's only now important for the values. At first I want to create the dot product, which basically calculates the angles here. So I want to look at the normals of the Suzanne surface, and then with vector math I want to create the dot product here from the normals and of course the location of this reference point here. And when we only look at that, we have the correct values, but we can't see it yet because of course the shader is not set up. So let's just create a new shader with just an attribute, and let's choose the attribute to, let's say, light. And in the export here, I want to export the light attribute, and now you can see it. So I'm exporting here the light attribute on this value, and here I'm importing it in the shader editor light value as the color of the surface. And now you can already see that only the angle is pretty much already considering the light calculation. So now areas or faces which look to my light source are now bright, and areas which look away are black or dark. And here you can see the transition area, pretty small already here. And now we just continue with calculating the light a bit more detailed, only one more step. I don't want it to be too complicated. Now we just multiply the distance basically. So for that, let's just use a math multiply over here, and I want to multiply now here the distance, which is the position, and of course here again the location. And now we can just take this vector math node to the distance and now calculate the distance between the location and the positions and multiply that here. And now we have one problem, because when we look at this solely, we can see that it's basically the other way around. Let's pin that here. That areas, of course, where the distance is low are dark, and areas where the distance is high are bright. Because the distance, of course, increases with the distance. And by this, we have a little problem, but we just have to remap it basically. And we can do it with a float curve, which we just invert so that high distance values result in low values. And I want to change this coordinate system a little bit with, for example, a higher value on the x-axis here, so that it's like this. Now we can put it on here, and now you can see how it's now. It's basically, as you can see, a sphere around this object here, which calculates then the distance value. And now when we, let's delete all of this, if we now take that into the calculation over here, and of course use the group input, which I deleted here, now you can see that we have a bit more detail. Yeah, so before it was only that, so no difference here in the distance. And now when we have this again calculated with it, now we have a brightness increase over the distance. And if this is too dark for you, you can increase it a little bit, that the minimum value is always a little bit here. But that's all right. For me, it's fine now. So I have now my fake light source, which looks okay. It's not very detailed, but for my purpose, it's perfect. And we can now proceed with the actual effect, which are these numbers on the grid. For that, I want to create a grid here. So let's just create some object here and add there another geometry nodes group. We can detach the group input and only use a grid for that. Then we have a procedural plane basically. And then, let's move it over here, for example. And with a transform geometry, we can rotate it a little bit. And to see it better, I want to enable the face orientation. Then I can see in which direction I want to rotate it, because I want to cast rays in this direction. So I want to use the blue face here, the correct face. So I use -90 degree, and now it's oriented correctly. So now I want to increase the scale of the grid, because I want to display it basically here. So let's increase the size, I don't know, to maybe this. That's okay. Like, I mean, we could use like 3 units by 3 units. And now I want to cast rays from the points of this grid. And to do that, I have to increase, of course, the amount of points on the grid. You can see that here. Now I have 100 by 100 vertices. And now let's do the raycast. To see what I'm doing, I will just use an icosphere, a very small one, to display the instances on points, and use that and here. So now I have an instance on every point here. Oh, that's a bit too large. Like this, that's fine. So let's look at it from the front and like this. And now I want to cast rays to make a selection here that only the rays where the monkey is hit are instanced basically. So let's add the raycast node and then use some parameters here. At first, the target geometry is of course Suzanne. On relative here again, use that here. Then my attribute is of course my light attribute. So named attribute light, I plug it in here that it reads the attribute on the monkey head. And now for the source position is of course the positions of the grid, and ray direction is the normal direction of this grid, which points at the monkey. And now we can use this information here, the attribute, on the selection that only my basically selected points where the attribute is not 0 are then spawned here. And you can see already the image of the monkey basically from the faces which aren't 0. So where the value is not completely black. And this is already dynamic, so you can move this and have this display of the brightness here on your map. Yeah, so, and by the way, by this you could do some pixel art if you spawn little squares here with different colors and so on. So with this you could do pixel art on the geometry surface and not with shaders. And now the only thing we have to do is to exchange these ball instances here to numbers or digits. And we will do this right away. So let's move this a bit to the side here. All right, so now we have to create a little setup for this. And we will start with 1 digit for the lowest values. So let's start with the digits I want to have on the black areas here. And I want to have the digit 1 for that, because the 1 covers only one line basically, which means it's not very bright, and so we can display dark areas with it. So let's create the digit 1 by just a string which displays a 1, and then a string to curve node like this, and then curve instances to fill curve on n-gons, for example. So, and this to here. All right, so you can see it's rotated in the wrong direction. So we have to use a transform geometry here and rotate it on the x-axis by 90 degrees, like this. And now I have to, of course, decrease the size because it's very, very large. So let's go to 0.1, for example. Okay, this is too large still. So you have to basically see the different lines here. So let's go with 0.03. Okay, so this is all right, I think. And here you can see it displays now the bright areas, which I don't want. I want the dark areas. And for that, I have to do a little arrangement here. Because currently here my selection only displays basically numbers which aren't 0. I want to cut that here or put something in between, which is a color ramp. And here I want to tell which part of the spectrum I want to display. And I want to display the dark areas. And because of that, you can see that here, I want to go to a very low value, let's say 0.002. So only dark values are displayed here. You can see this here, but now you can see a lot of noise around everything here. This is just because nothing is hit here and it's a 0 as well. And to avoid that, I want to delete these areas basically. And I want to do this with a Boolean operation and delete everything, the geometry which isn't hit before I instance something. So I want to use a Boolean math on not. So this asks is it hit, and I reverse it basically. So this asks is something not hit, which is everything around here. And if it's a yes, then I should delete the geometry and I will put it in between here. And now it deletes all the geometry which isn't hit. So I have to move this a bit away to keep it tidy. So if something is not hit, it will be deleted. And so you only have now the dark areas here. And now what we're gonna do is just put 3 times the same tree basically. Not exactly the same, but just a copy of it, a bit modified. One by another. So let's copy all of this here. 1 step down, and then put it to a medium covered digit, which is, for example, a 4, which has not that much surface, but more than a 1. And here we want to plug all of this in here too, except for that. This is exclusive for this. So let's arrange that more visible here, like this. And here I want to make my own color ramp and connect this here too. So let's tidy that up a little bit like this. Of course, we need the geometry from here too. So like this. And now I want to join the geometry from these two here in the end. And now I have my 4 digits here everywhere, Let's put this on the selection. And now the 4s and the 1s are in the same place, but we want to remap it here. So this goes from, so the 1s go from 0 to 0.002. So here we want to start on 0.002 basically. So let's put this on here. A black indicator on 0.002 and the white here in the center. And we will be dark again, so on black, which is 0, on 0.33, which are the medium values. And now you can see that very dark values are now exclusively for the 1s here. And then the medium values, which is this area here, is exclusively for the 4s. And by this you have now a medium coverage for the 4s and yeah, a low coverage for the 1s. And by this is a bit brighter when you look at it from far away. Maybe let's disable the Suzanne. The 4s are a bit brighter than the 1s because the 4 covers more space than the 1. So let's do this a third time with 8, which is the digit with the most area coverage. So copy this here, put this to an 8, then connect this again and connect the points here again like this. So now the 4s and the 8s are double here. And here we want to, of course, start from 0.33. So we can delete one of them and yeah, go to 1. And by this, we have now everything covered here, basically. The very dark areas, the medium areas, and the very bright areas. And now we have 3 different shadings, basically, without using an actual shader, just by raycasting the attribute of the monkey to this grid, which acts like a screen here. Okay, so in the end, I want to use a material. Let's quickly create one. Emission white, and then just create a white emission. Set the material here, emission white. And now let's disable Suzanne for now. So let's look at it from the camera, and here you can see the current result. We now have a geometry nodes tree, which displays the brightness of our self-created light on the monkey. And then this attribute is read by the grid, which displays these 3 different digits, then depending on the light on this invisible Suzanne here. And yeah, let's make this more comfortable to use, to make some connections here. Because here the grid size, we want to make this all procedural and adaptive to everything. And because of that, I want to make some calculations here. So at first, I want to make the grid size here bound to a value. So let's put this on here. So I mean the resolution, not the size. The size should be the same. And now we can decide the scale of the grid here. So the resolution, how many digits we want to have in every row and column here. So for example, 50 by 50 or 100 by 100 or 300 by 300 like this. Yeah, it overlaps maybe a bit then. So let's keep on 100 by 100. And I want to, of course, change the size of the letters, accordingly to that nothing overlaps here. So the letters or the digits get smaller when I increase the resolution. And to do that, I want to use a math node on divide, like this, and divide 100 by this value here, and use this as the size for now. And you can see it's of course way too large here. And because of that, I want to use another math multiply here and multiply the value which was in there before, 0.05 or something. And then this is all right. And now we just do the same thing basically here. Math multiply and then 0.05 and use that over here. Math multiply and use that over here. 0.05. And I did that 3 times. You may wonder why 3 times. We could do this with only 1. Yes, that's because you can now change the size of the digits individually, because maybe you want to have the ones a bit smaller to have this dark area, yeah, to give it more contrast. For example, if I go here to 0.15, then you can see now that it's way darker because you have less bright areas in there. And on the 8, maybe you want to be a bit larger. So let's put this on 0.35. Now the 8s are larger and the 1s are smaller. And now you can already see this results in way more contrast because, yeah, the 8s are larger and cover more areas which are bright then due to the number surface. So yeah, this is the reason why I did it 3 times, because now you have individual things, yeah, for everything. And because I bound it here to the grid size, you can now change the grid size and then the numbers will change their scale, yeah, procedurally to that and adaptive, and it will always be the same grid basically with yeah, the different resolutions. So let's keep it at 150, for example, which is more detailed, or 50 to be more rough and pixel art style. So, but let's keep the default 100 where I started. And now it's basically finished, yeah? So now you build something which is totally adaptive, and you can now, yeah, create light settings for your object here. Of course, you can just exchange the object now and, yeah, exchange some objects nodes here, for example. Yeah, so now you can use any object, display some light on it and present it, or basically render it. It's something like a second render engine in the render engine. So this is like a screen where you render your pixels on. And now we have, yeah, 2 render engines in one basically, where we render on the screen the light attribute and then we render the digits on this screen to the final video or picture. And now we can just, yeah, play around with it and animate it dynamically and, yeah, display it just like this. And now we're finished with this video. Thank you for watching. If you found this educative or helpful, consider a subscription or check out my Patreon. Have fun playing around with your self-created light and see you soon in the next video.